A triangle definition was a good start, but it has some limits. The biggest one is that we can only use it to find the values of angles that can occur in a right triangle, that is to say, acute angles. Practical applications, for example, spinning parts, are often going to involve angles outside of that range, so we need definitions with a broader domain. So suppose we start with a unit circle, right? That is a circle whose radius is 1. And I'm going to start by drawing an angle in the standard position, like this one. Now the way we're going to define the sine and cosine using this circle is based on the coordinates of this point, right? The x coordinate of this point is going to be the cosine of the angle, and the y coordinate is going to be the sine of the angle. Okay, now before we go any further with this, I want you to see that when we're talking about an acute angle, like the ones we could get in a right triangle, we get the exact same results here that we did with our right triangle definitions. And to see this, I'll draw a right triangle here based on our angle. Right, now the base side of the triangle, let me get this 1 out of here. The base side of the triangle is going to be x, and the height of the triangle is going to be y. Now, remember that the hypotenuse is a radius of the circle, so its length is going to be 1. All right, so now you can see, right, that the sine of theta is the opposite side, that's y, divided by 1, which is just y, and the cosine of theta is the adjacent side, that's x, divided by 1, which is just x. So we are getting the same results, right, for the triangles we already knew how to do. This definition is not replacing the existing ones that we have. It's just extending it. Okay. So now we can work with any angle, right? For example, suppose I wanted to find the sine of, say, 90 degrees, an angle that we couldn't do before, because you can only have one 90-degree angle in a right triangle. All right, well, let me draw a 90-degree angle here in the standard position. All right, now this the terminal side here crosses the circle at the point 0, 1. And that answers my question. That means that the cosine of 90 degrees must be the x-coordinate of that point, that's 0, and the sine of 90 degrees must be the y-coordinate, which is 1. All right, so now, let's see if you can work through this same process to find the sine and cosine of 0 degrees. All right, so what's a 0-degree angle look like? Well, the initial side is on the x-axis, positive x-axis, just like it always is. And the terminal side of a 0-degree angle, well, it's going to be this same side. It's going to be lying there right on top of it. So the point where the terminal side crosses the circle is at 1, 0, which means the cosine of 0 degrees is 1, and the sine of 0 degrees is 0. All right, so great. Now, how about the other one? How about the tangent? Right, well, to find the tangent, remember that the tangent is equal to the sine divided by the cosine. So looking at 0 degrees, the tangent of 0 degrees is going to be 0 divided by 1, which is 0. And the tangent of 90 degrees is going to be 1 divided by 0, which is undefined. Right? It's undefined. Can't divide by 0. All right. So this is the table that we looked at in our last lecture, but with 2 rows added. One for 0 degrees and one for 90 degrees. Now I'm going to fill this in, but I'm going to do this in a specific way that I think makes it really easy to recreate, which is going to help you remember the values. All you have to do is remember the pattern and that the sine of 90 degrees, the sine of 0 degrees is 0. Then you can get the other values very quickly. All right, so here's the pattern. I'm going to do the sine first. First, the denominator is always 2. So it's always going to be divided by 2 for all 5 values. Now, watch how I write the numerators. Okay, I'm going to write the numerators a little unusual, but just give me a second, and you'll see why. I'm going to do the square root of 0, the square root of 1, the square root of 2, the square root of 3, and the square root of 4. Those are our values. All right, but look, simplify these. The square root of 0 is 0. 0 divided by 2 is 0. Square root of 1 is 1, so this is 1/2. Okay, the square root of 2 and the square root of 3 I can't do anything with, so those are going to stay just the way they are. The square root of 4 is 2, and 2 divided by 2 is 1. And that's it. You filled in the entire first column. Right? The entire first column is done. Now, we need the values of the cosine, but look, the values of the cosine are exactly the same as the values for the sine, but in reverse. So instead of starting at 0, I'm going to start at 1, then the square root of 3 over 2, the square root of 2 over 2, 1/2, and 0. And then to get the tangent, it's just the sine divided by the cosine. 0 divided by 1 is 0. 1/2, I got to make that a little smaller. I got carried away because I got to put 2 fractions here, right? 1/2 divided by the square root of 3 over 2 is 1 over the square root of 3. And if you rationalize that, it's the square root of 3 over 3. All right, then the tangent is the square root of 2 over 2 divided by the square root of 2 over 2, which is 1. Then let's see, square root of 3 over 2 divided by 1/2, which is the square root of 3. And finally, 1 divided by 0. Please don't say equals here. This one, okay, this one is the one kind of weird exception. This is undefined. And I really want to emphasize that part. Please don't try to get creative with how you describe the tangent of 90 degrees. It's undefined. Please don't say equals undefined, that it's making out like undefined is somehow a number, and it's not. Please don't say infinity. 1 divided by 0 is not infinity. Really, the only proper way to express this particular result is to say it's undefined. Okay. So that's how we find these values, right? Now we can find the trig value of any angle between 0 and 360 degrees, including 0 and 360 degrees. So now that we have our new definition, we've seen how to use it, we've calculated some values. In the next lecture, we're going to see how we can use this to find all of the values of specific trigonometric functions for specific angles.